Guys, this is Miss Humbert here, and today we're going to start by talking about Unit 2, Notes 5. So today we're going to talk about proving if lines are parallel. So you actually already have all the information you need to do this because we've done it before. We're now just going to kind of take it and put it into reverse. So let's take a look at what that would look like. So there's going to be a lot of writing today, so you need to make sure that you pause the video and get everything fully written down because we're going to be doing a lot of theorems, and you need to have all of those theorems in order to be able to prove that lines are parallel. So please make sure you have them all written down. So first and foremost, if we're going to talk about the converse of corresponding angles postulate. If two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Well, that seems kind of confusing. That's a lot of words. Basically, all that's saying is if we know that two corresponding angles are congruent, then the lines that are associated with them have to be parallel. So, for example, let's kind of write out some statements of this example here of what that would look like. So, for this, if angle 1 is congruent to angle 3, or angle 2 is congruent to angle 4, remember corresponding angles, they're sitting on the same side of the transversal. So, upper left for 1 and 3, upper right for 2 and 4. Or if 8 was congruent to angle 6, again, lower left, or angle 7 is congruent to angle 5, lower right, then we can safely say that A is parallel, remember those two lines mean parallel, to B. So if those are corresponding angles are congruent, then A is parallel to B. Let's take a look at this in practice. So given the following information, is it possible to prove that any of the lines shown are parallel? If so, state the postulator theorem that justifies the answer. So we know that angle 1 is congruent to angle 3. Well, these two angles are corresponding. Well, since they're corresponding angles, then yes, we can say that A and B are parallel because 1 and 3 are corresponding angles to the lines A and B. And that's going to be by the corresponding angles converse. Okay, so I was just putting that into practice. Taking a look at the next one, parallel postulate. If a given line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. So here we have line M, and we have point P. So we just picked a point that wasn't on the line. So what this postulate is saying is that through this point, there can only be one line that is parallel to M. There can only be one line where the slopes are the same going through that point. Because if it was slightly different, then it wouldn't be parallel. So there's only one line going through point P to make it parallel. All right, let's keep moving forward. So let's take a look at the alternate exterior angles converse. So if two lines in a plane are cut by a transversal, that's what we've been talking about this whole unit. If two lines in a plane are cut by a transversal so that a pair of alternate exterior angles are congruent, then the lines are parallel. So remember that alternate exterior angles are going to be these guys right here. So what we're saying then, if we know that angle 1 is congruent to angle 3, then we can say that P, that should be a 3, that P is parallel to Q. And that's going to be by the alternate exterior angles converse. So if we know the alternate angles are equal, then P and Q have to be congruent. Parallel. Let's take a look at this next one. We're going to take a look at the consecutive interior angles converse. If two lines in a plane are cut by a transversal, again, that's what we've been dealing with. All that's saying, this transversal is cutting through these two lines. That's all that statement is saying. So that a pair of consecutive interior angles is supplementary. Now remember that supplementary means it adds to 180. Then the lines are parallel. So all that's saying is if we know that angle 4 plus angle 5 is equal to 180, then if that statement is true, then P is parallel to Q. So we're kind of doing the opposite of what we were doing in the previous parts of this unit where we were trying to decide whether or not angles were equal, already knowing that they're parallel. Now we're using the fact that we know they're equal to prove that they are parallel. Let's take a look at a couple more. So let's take a look at the alternate interior angles converse. So if two lines are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are congruent. So what we're saying here are a pair of alternate interior angles. They're both on the inside and they're on opposite sides of that transversal. So what we're saying is if we know that angle 6 is congruent to angle 8, then we can say that P is congruent to Q. Again, if the alternate angles are congruent, alternate interior angles are congruent, then the two lines are parallel. Last but not least, let's take a look at this one, the perpendicular transversal converse. In a plane, if two lines are perpendicular to the same line, then they are parallel. So what we're saying is really that's a lot like corresponding angles. If this is a right angle and this is a right angle, then these two lines have to be parallel. Well, think about it. If it wasn't, okay, if this right here was a right angle and this wasn't a right angle, eventually those two lines would cross. So if they're both right angles and then to the same transversal, then they have to be parallel. That's all that is saying. Okay, so what we're going to do now is we're going to work on proving lines are parallel based on what we know. The biggest thing when you're proving things as geometry is that you have to state the theorem that's associated with it. So if we're talking about, we're saying, okay, well, yes, I know that means they're parallel. Well, you have to tell me and whoever's looking at your sheet why that means they're parallel. So let's take a look at this first one. Given the following information, is it possible that any of the lines shown are parallel? If so, state the possible theorem that justifies your answer. So first and foremost, we're taking a look at number 2. Okay, so it's saying that 1 and 6. So I see that that's dealing with this line N and this line L. So what I notice is that they're on the opposite sides of the transversal and they're on the outside. So that makes them alternate exterior angles. Well, it gives me that angle 1 is congruent to angle 6. Okay, and I know they're alternate interior angles. Well, if the alternate interior angles are congruent, then yes, we can say that L is parallel to N, and we can say that's true by the alternate exterior angles converse. Okay, let's take a look at the next one. Now it's telling us that angle 2 is congruent to angle 3. So now we're dealing with line M and line L. So I notice that those two angles are on the interior, and I also notice that they're on opposite sides of the transversal. Well, if angle 2 is congruent to angle 3, then our alternate interior angles are congruent. So we can say that L is parallel to M by, now we're going to use alternate interior angles converse. Okay, again, we have to state the theorem as to why that they are true. Let's take a look at this next one. Given the following information, is it possible to prove that any of the lines shown are parallel? So we're going to do the same thing. So let's take a look at lines 2 and 8, or 2 and 8. So I see that I'm going to be dealing with lines A and B. So I'm going to pretend that line M doesn't exist. So line L is going to be my transversal, and A and B are my potential parallel lines. Well, I see that 2 and 8 are on the inside, and they're on alternate sides. Well, if 2 is congruent to 8, that means that A is parallel to B by alternate interior angle converse. Alternate interior angle converse. Okay, next we want to see what 3 and 11. So now I'm looking at lines L and lines M for 3 and 11. So for this one, we actually have to go all the way back to the very first postulate we learned. Okay, 3 and 11 are corresponding angles. Okay, that makes A our transversal. Okay, so they're corresponding angles. And so if their corresponding angles are congruent, then the lines are parallel. Okay, so yes, we can say then that L is parallel to M, and that's going to be by that first postulate we learned, which is the converse of corresponding angles postulate. All right, next, let's take a look at angles 1 and 15. So again, now I'm looking at A and B. So I notice that 1 and 15 are both on the outside. And since they're congruent, that's going to make A parallel to B, and it's going to be by the alternate exterior because they're alternate exterior angles. So alternate exterior angle converse. So we're still identifying the same angle relationships we were doing the entire unit. Moving forward, let's go ahead and let's take a look at those word problems. In the ladder shown, each rung is perpendicular to the two rails. Is it possible to prove that the two rails are parallel and that all of the rungs are parallel? If so, how? Explain. So what we're noticing is here are our two parallel lines. Each of these are transversals going through our parallel lines. Well, each rung is perpendicular to each side of the ladder. And so we have two parallel lines with the transversal that's perpendicular to each. So yes, we can say that they're parallel. We just need to say how we know that. So now we're going to flip back to that perpendicular. So we can say that they're parallel by the perpendicular transversal theorem. Okay, so that's using all those theorems. So when you're going through your homework, I really suggest you have that note sheet out so you can kind of flip through these as you're going through. Okay, next. Let's take a look at that last problem. In order to move straight with maximum efficiency, rowers' oars must be parallel. Wow, that is hard to say. Okay, so refer to this photo. Is it possible to prove that any of the oars are parallel? Well, if not. Okay, well here's what I know. This is 80. Okay, well what I'm going to do is I notice that 80 and this angle right here form a line, so they have to add up to 180. So 80 plus x, 80 plus x needs to equal 180. Well, then that makes x 100. So this angle right here has to be 100. Well, I notice that this angle is 110, and that angle plus this angle, that's going to add up to 180. So now for my next one, I'm going to have 110. Oh, that's hard to see. 110 plus x is equal to 180. Well, that is going to make x equal to 70. So this angle is 70. Okay, so now if we flip back to our theorems, according to the consecutive interior angles converse, these two angles need to add to 180 in order for these two oars to be parallel. Well, 100 plus 70 is not going to be 180. So no, they aren't parallel because they fail consecutive interior angle theorem. Okay, so that concludes your note video today. Again, while you're doing your homework, please have these theorems out. They will greatly help you. Thanks for listening.